Every year, new computers hit the market, each one faster, smarter, and more efficient than the last. But have you ever stopped to wonder what it really means when a processor is called 12th generation, 13th gen, or even the exciting next gen? It sounds like a simple marketing term, but it's so much more. In this video, we're going to decode the mystery behind generations in computer technology. And trust me, you'll discover why they matter a lot more than you think. So, what does generation really mean in the world of computing? Essentially, it refers to a major technological upgrade in a line of hardware or software. Think of it as a significant leap forward in design, performance, and efficiency. When we talk about processors, like Intel's Core i series or AMD's Ryzen chips, a new generation signifies a new architecture. This isn't just a minor tweak, it's a fundamental redesign of the chip's inner workings. We're talking about redesigned transistors, improved power management, faster clock speeds, and better support for emerging features like AI acceleration and high-speed memory. For a concrete example, let's look at Intel. Their 10th gen Comet Lake processors were built using a well-established 14-nanometer technology. A couple of years later, the 12th gen Alder Lake processors arrived, introducing a groundbreaking hybrid architecture. This new design combined powerful performance cores for heavy tasks with smaller efficiency cores for background processes. Each step forward isn't just about being faster, it's about being smarter and more optimized for how we use our computers today. The concept of generations isn't new, it actually dates all the way back to the 1940s. The very first computers, massive machines that filled entire rooms, used vacuum tubes. We call this the first generation of computers. Then, in the 1950s, the second generation arrived. With transistors replacing those bulky, hot vacuum tubes, this made computers smaller, cooler, and more reliable. The 1960s brought the third generation, defined by integrated circuits, or ICs, which packed many transistors onto a single chip, revolutionizing computing once again. The fourth generation, born in the 1970s, gave us the microprocessor, the brain of modern computers, and that brings us to the fifth generation, which started in the 1980s and continues to this day. This era is defined by the rise of artificial intelligence and early quantum-inspired technologies. So when we talk about a processor's generation today, we're not just counting years, we're tracking the incredible evolution of human innovation. Let's dive deeper and focus specifically on CPS. Each new generation typically brings improvements across several key areas. First is the architecture, which is the internal structure and logic design of the chip. Then there's the process node, which refers to how small the transistors are, measured in nanometers like 7 nanometers or 5 nanometers. Smaller transistors generally mean more power and better efficiency. We also see increases in clock speed, which is how fast each core can perform tasks. A huge focus is also on power efficiency, leading to less heat output and, for laptops, much longer battery life. And finally, integrated graphics get a boost, giving you better visuals without needing a separate, expensive graphics card. For example, Intel's 13th Gen Raptor Lake processors delivered up to a 15% improvement in single-core performance and an incredible 41% jump in multi-core performance over the 12th Gen. This was achieved through optimized cores and support for faster memory, showing how a single generational leap can have a massive impact. But the generation label isn't just for processors. It applies across the entire tech ecosystem. Think about your computer's memory, or RAM. We've moved from DDR3 to DDR4, and now to DDR5. Each new generation roughly doubles the bandwidth and improves efficiency. The same goes for graphics cards or GPS. NVIDIA 20 series, 30 series, and 40 series cards each introduced massive advancements in features like real-time ray tracing and eye-powered rendering. Even wireless technology follows this pattern. We went from Wi-Fi 4 to Wi-Fi 5 to Wi-Fi 6, and now Wi-Fi 7 is on the horizon, with each step bringing higher speeds and lower latency. And don't forget storage. We've evolved from slower SATA SSDs to lightning-fast NVMe Gen 5 drives, each new generation drastically cuts down the time it takes to transfer data. Every new generation in every component means fewer limitations and more possibilities for what we can create and experience. So, why does all this matter to you, the consumer? Well, a newer generation usually translates directly into tangible benefits. You get better performance for multitasking, meaning you can run more apps smoothly at the same time. You'll often see improved battery life in laptops, which is always a welcome change. A newer device is also likely to have a longer lifespan, as it will be able to handle future software updates more effectively, and it will support the latest standards, like PCIe 5.0 for ultra-fast components or DDR5 memory. But here's the key: newer isn't always necessary for everyone. If you're a casual user who mostly browses the web, sends emails, and watches videos, a 10th Gen Core i5 processor might serve you just as well as a 13th Gen one, and you could save some money. However, for content creators, engineers, programmers, or serious gamers, that generational jump can mean real-world time saved on rendering, compiling, or loading. And it future-proofs your investment for years to come. What does the future hold for computer generations? As we move toward a world dominated by artificial intelligence, the line between hardware and intelligence itself is starting to blur. Future generations will be even more specialized. We'll see the widespread integration of neural processing units, or NPUs, which are dedicated chips designed for real-time AI tasks right on your device. We'll also see incredible innovations like 3D chip stacking, where processors are built vertically to pack more power into smaller spaces. And we're on the cusp of hybrid computing models that will combine the power of classical computers with the potential of quantum cores. The next generation of computers won't just process data, they'll understand it. From the room-sized vacuum tube computers of the past to the AI-driven processors of tomorrow, every single generation marks a new milestone in human progress. So the next time you see 13th Gen or Next Gen on a product box, remember that it's not just a marketing number. It's the story of how technology continues to evolve, constantly pushing boundaries to make our world faster, smarter, and infinitely more connected. Thanks for watching. If you found this video helpful, be sure to hit that like button and subscribe for more tech deep dives. See you in the next one.